Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Fadi Fitri bin Muhammad Ismail. Today I will present about physics and instrumentation. Okay, before we go through detail, I will remind uh, all of you as a sonographer and technicians. We must remember for the basic physics of ultrasound have five characteristics. Firstly, amplitude. Second is frequency. Third is wavelength. Fourth is speed. And last is period. Clinical ultrasound diagnostic potential depends on understanding and exploiting numerous physics principles. Ultrasound function depends on ultrasound wave emission interaction with tissue densities with reception and machine data processing. Different probe types transmit sound wave at a varied frequency, depth, direction, focus point, and power to enhance ultrasound imaging. Motions and artifacts management methods are also used. Ultrasound is sound with a frequency higher than 20 kHz, which is the highest frequency that human can hear. A electric crystal, which is a source of variation, is in an sensor make diagnostic ultrasound. And then one more thing is there are three types principle related to annotation. First, absorptions, second, reflection, and third, refractions. Okay, how depth, zoom, and focus affect image quality. Firstly, I will explain about depth. The depth of field is how far sound wave can travel and be picked up. To get the best power and temporal positions from the machine to see target structures and displays depth is changed. It is important that the depth is both deep enough to see deep structures clearly when needed and short enough to see shallow structures clearly. The quality of the target structures picture is worsened when the depth is set to deep for close inspection. For the focus, the narrowest area of an ultrasonic beam called the focal point in the near field. The ultrasound console focus button adjusts signal focus on structures of interest. This improves signal resolution at the point by increased signal dispersion in the far field. Deeper structures may appear gainer. And then lastly, for a zoom, the zoom capability lets sonographer this view structures in detail. It does not modify image resolution. Those structures may appear gaining it help measure to the imaging caliber. So this is an image or picture for the echo machine from the echo machines ultrasound machine. For if you can see here is very clearly the TGC depth focus gain modes and then on off button, the 2D screening gain, uh, and then the so the functions, all of this is important to adjust, to maintain, and uh, to see the image, quality image, so doctor can uh, see the clearly of image ultrasound. So this is for example image for other IoT valve, left right atrium. So image above and beyond the left illustrate increase the deep and or field. The left atrium become more defined and the resolution improve. The left ventricle appears smaller. Imagine C and image C and D on the right show the effect of zoom on the IoT valve. And then we go. So this is a focus image. So this one is a poor resolution on the left side, and then the right side improve resolution. This means the more focus uh, zone. Okay, and then the axial and lateral resolution. A higher resolution system can identify to separate reflectors that are close together. In beam modes imaging, actual resolution distinguish between two reflectors that are close together along the same line of sight, while lateral resolution distinguish between two reflectors that are perpendicular to the line of sight. And image resolution is the capacity to resolve or distinguish between two closely located eco-producing tissue reflectors. So for the, I mean the conclusions for the axial and lateral resolution, they have a four factor. Firstly, frequency. Second is pulse length, and third is beam width, and lastly depth of imaging. And then we go through for the time gain compensation. Gain is the amount of the power going out to the power coming in. The gain rise the amplitude of the returning ultrasound information. This is similar to turning up the volume on a stereo, but the ultrasound wave goes deeper into the tissue. It weakens, weakens. So the signal can come back is also weak. This makes the signal in the near field close together the transducer and the far field, far farness from the transducer and events to get the grayscale picture that is a balance in the near and far field. Time gains compensation is used to fix signal that change with time and depth. So for the optimization image quality, adjusting by 2D gains, clinicians can enhance visualizations of cardiac chamber like a valve wall and other anatomical structures. 2D gain setting may need to be adjusted based on the factors such as patient anatomy, body habitus, chest wall thickness, depth, and such of interest and specific imaging goal. And then we go for the next view. So you can see from left, first image show overuse of gain, and the second image at the center is to doubt for the lack of gain, and third image is show appropriate use of gain. So this is can adjust by 2D gains and TGC also. And then I will explain the near field, far field, and focus zone. But the focus zone just now I just present the previous slide. So of the main job of an ultrasound transducer is to send ultrasound wave in certain way just past the near field, which is part of the picture that is close to transducer. Ultrasound tend to first coverage to a narrow beam that has the best solutions. The focal zone is this spot. Ultrasound wave quickly split apart into the far field, which is the area just outside the focus zone, even though the focus zone has the best image clarity. The area of interest may be in near or far field and not in the focus zone. For the mechanical transducer to work, they need to lens that the connections to them and project a narrow beam to the single point in the view in single point in the field of view. Electronic linear or step sector transducer can change the focus zone depth or make the focus zone at the same times. The technician can place the ultrasound beam on the small area which make image quality is better. So if you can see, this is a picture, uh, the TGC, the gain, near, far, and overall the gain. This is a picture, and then the okay, lastly, we talk about the discussion. The realities of the patient body habitus may make it difficult acquire an image regardless of how skilled the sonographer is or how advanced the technology is. It is common practice to adjust the position of the patient in order to achieve the best possible acoustic window. The patient is positioned in the left lateral decubitus position. For the instance, the heart will be brought close to the chest wall and to the transducer. Another essential aspect of picture acquisition in the ability to rotate, tilt, and angle the transducer in order to achieve the desired result. This ability can only be obtained by consistent practice and a dog determination. Okay, for the conclusion, to gain the capacity to acquire and correct interrupt and interpret ultrasound image, it is necessary to have a fundamental understanding of the fundamental physical precision that underlie ultrasound. The sonographer will be able to maximize the potential of the device modality if they have a deep understanding of a few fundamental principles. Discrete, discrete defects and ultrasound physics can appear to be somewhat complicated. So this is our my reference. And then lastly, thank you for the attentions. Thank you.